Thank you so much for joining us today for a conversation on empowering data stores for hybrid cloud. We really appreciate you sharing your time with us for the conversation, and we hope it's interactive. I'll cover a little bit of logistics here in a minute, but we're really hoping for an interactive conversation, not us presenting. Just curious to hear from you on all the topics we cover as well. My name is Jeannie Glass, and I'm CEO at VirtualZ Computing, and with me today is Mark Potts, Head of Global Services. Before joining VirtualZ, Mark led mainframe modernization at Accenture as part of his 17-year career there. And here at VirtualZ, he leads our consulting services practice, delivering solutions for mainframe and cloud data access to customers and consulting with customers on their mainframe modernization projects. The call today will be recorded, and after the call, we'll share with you the recording as well as the slide that we're going to cover. And feel free to submit your questions into the chat at any time. And we'd like to take those, as I said, interactively during the discussion. But we will also open for a conversation and Q&A at the end of the call as well. We're going to cover understanding data stores. And again, please, chime in with your thoughts and perspectives. We'd like to learn from you as well. We'll talk about customer use cases and then the advantages of VirtualZ software for your data stores and your business. With that, I'll turn it over to Mark to get us started. Thank you.
All right. Thank you, Jeannie. I appreciate it. And as Jeannie said, thank you everybody for joining today. I appreciate it. Yeah, as Jeannie said, we're going to get into data stores. I've also added a little bit of a section around storage as well, because we do get a lot of questions around data stores as well as storage, and how our products at VirtualZ help move data to data stores or use data stores as well as storage. So a little bit of background on VirtualZ. We are a mainframe startup and woman-founded. Jeannie's our founder. And as far as we know, as we've been told by IBM, we are the first woman-founded IBM software company out there ever. So we are unique, we are special, and we have a unique opportunity to really transform what's going on with the mainframe and help our clients around data access. When it comes to the needing data in the cloud or off the mainframe, to do either analytics or replicate the data to data stores or to run AI models, or even use modern storage capabilities like the cloud providers to reduce some of the costs of the mainframe. So all our products have really been focused on how do we improve business agility, how do we reduce the talent challenges of the mainframe, and how do we do both of those things with also making sure that we don't increase the cost of the mainframe. So when I talk about business agility, how can we gain easy access to data and be able to do new things like analytics, reporting, AI tools? How do I use our products so that it doesn't require a mainframe expert or several mainframe experts to actually implement our products? And then from a cost standpoint, we often see when people install new products on the mainframe to improve the access to legacy data on the mainframe, it can dramatically increase the cost of the mainframe. Whether that's an ETL tool, whether it's change data capture, or maybe it's event-based architectures where you're replicating the data back and forth based off looking at logs or other events that you put on an event queue, for example. Just to recap real quick on our products, for those who might not know, we have three main products. The first one is Lozen. That was the first one we brought to market. Lozen is real-time access to data on the mainframe. So if you have decided that you want to keep the system of record on the mainframe, Lozen is the product for you. So the data stays where it is. We provide full read-write access to that data, especially around flat files, VSAM files, QSAM files, just like you would be if you were on the mainframe. ZAC is a product that's coming to market in the next couple months. It allows you to do the opposite of Lozen, where the system of record essentially is in the cloud or off the mainframe on a distributed server, maybe in a hybrid cloud or a private cloud environment, for example. You can leverage the storage capabilities as well as we'll talk about the ability to write to data stores as well with ZAC. So the data looks like it's on the mainframe, but it's actually the system of record is actually sitting off the mainframe. And then Propels is a product we brought to market very quickly over the last few months. We got a significant amount of requests around data replication and being able to take complicated historical mainframe data like VSAM and replicate that to a modern data store. And I'll get into details around that and on how that works. So as I get into the details of our products, I just want to level set with everybody what we mean by data store and storage. I'm sure this is obvious for people, but just I think it's good sometimes just to ground ourselves. So really on the data stores, we're talking about data warehouses, databases, data lakes, and even file systems. And file systems is something we'll touch on with a decent amount when we cover Lozen. Storage, right? We're talking about virtual disks or virtual drives. We're talking about products like S3 and EMC or Dell's storage capabilities, Hitachi and IBM storage capabilities. We're also talking about Azure storage and Google storage as well, right? So being able to store documents in large volume sets off the mainframe, but again, make it look like it's the data is actually on the mainframe. All right, so just a real quick summary for those who might know a lot about Lozen. Lozen is a product, and all our products, just to level set, primarily run on the mainframe. So Lozen is something you install on the mainframe. It is essentially enables NFS connectivity to applications and servers off the mainframe, and so you can then view the files on the mainframe as if they were local to your server, your application running off the mainframe. So again, the main protocol and interface with Lozen is NFS. With that, we also have the ability to return and do data transformation. So if you wanted to read a file, a VSAM file, and you wanted to return a record in JSON or XML or CSV, you provide the key, you provide the file name, and it'll return that data to you as the format that you specified. We also have connectors into Lozen that I'll cover in more detail here on the next slide. But those connectors allow you to do simple integration into those files. So they're open API connectors. There's a MuleSoft connector. There's a Micro Focus connector, and then there's a Lozen-based API as well. You're not required to use those connectors to interface with Lozen. It's a very open product, so you could use native NFS, develop your own connectors just through Java or whatever you want to use, what language you want to use. But basically, you use the NFS mount and NFS client on your server to interact with Lozen and provide data back. So because it is open and because we've also built those APIs, many of our clients will use Lozen to do full read-write access and transactions to Lozen, to their files through Lozen. So doing a read, write, update, Lozen could do all those things. But we're also starting to see the need for ETL tools to also access that data. Many times we see ETL tools, they have to be installed on the mainframe, or you've got to create complicated APIs. And then underneath those APIs, you've got to create a Kix transaction, or you're going to use COBOL or something else. You've got to develop a bunch of code to really get access to that data. With Lozen, you don't have to do any of that development. Lozen again has APIs, and I'll just focus on our open API here first. But basically, you could pull in to your ETL tool as long as there's API capabilities, which I'm pretty sure all of them do on the market. But if you wanted to use Informatica in the cloud, you can ingest in our open APIs and then have that full read and write capabilities of Lozen to pull data out of the mainframe, out of a VSAM file or a QSAM file or a flat file, and write that data to any of these data sources I have on the right side. So if you're a Snowflake customer and you want to get to VSAM data and you want to pull it, Lozen is a great solution for you. Like I said, it's taking our open APIs, or if you want to create your own open APIs, you can do the same. You can do that as well. But basically, you use your ETL tool to extract that data and replicate that data into Snowflake. And now you're up and running to do your analytics, your AI modeling, whatever you want to do with Snowflake, for example. And we don't care where the data source is, right? So obviously the ETL tool will transform and then write that to a database that's sitting on any of the hyperscalers or on a distributed server outside of the mainframe. Propels is a utility that runs on the mainframe, and it ingests. So you tell Propels, it's command line. You tell Propels the file you want to replicate, or the data source, right? So let's just say again, it's a vSAM file. You tell it the copy book that you want to use, and then you've configured the data source to whatever data source we have on the right-hand side. Propels can connect out of the box to over 100 different data sources. We leverage JDBC, as you can see in this diagram. So as long as there's a JDBC driver, we can replicate and write to that data source. Out of the box, Propels can cover about 100 different data sources. So a lot of the big ones that are on the market, Snowflake, Databricks, S3, Oracle, MySQL, Postgres, BigQuery, we can write to all those out of the box. If for some reason our JDBC driver does not support the database you're trying to write to, we can take that, as long as there's a driver out there on the market, we can bring it into Propels, configure Propels, and write to that data source as well. So as I was talking about, so we take in the file, you specify the file, you specify the copybook that we will use for the metadata, and we will look at the copybook, look at that metadata, create a schema if it doesn't already exist on the target side, and the data sources on the right, and write and pull that data out of the vSAM file and write to those data sources. We can handle arrays and create relational models based off the array. So you could have a subtable for the array, and then you've got your join up to your primary data data or row. So you've got that relational model, if you will. So you can take a vSAM file that has arrays in it. It'll have a relational model as the output into MySQL, for example. We transform the data, so it's in something that you can easily read, consume. So if you wanted to write to Snowflake and you wanted that data accessible right away, it'll be accessible right away. And you don't have to do any sort of other transformation of the data or anything else with Propels. So pretty straightforward. So you can imagine that you might want to write a cron job that replicates the data every minute, every hour. You could also do it every second. And Propels will do incremental updates. So if you move the first 10,000 rows of a vSAM file and you call Propels and execute Propels again, it'll start reading where it left off and move the next 10,000 rows if you wanted to. And so it's very streamlined in the sense that you're not going to replicate. If you've got a terabyte file, you're not going to replicate that every single time. So that helps with your MIPS usage. That helps with your networking. It also helps get the data up there faster and speed, obviously, so you can use it in near real time. Obviously not real time. That's something that we're considering for the future, but in near real time for now. All right, the next product we have is Zach. And so again, Zach, if you guys remember when I opened up, it's kind of the opposite of Lozen. The real first use case we're going to use for Zach, and we will have a webinar next month that goes into this in a lot more detail, is basically virtual disk. And so Zach can mount and take a file system that Zach manages and mounts to, let's just say for today, we talk about S3. Instead of using DASD as your storage, Zach will now use S3 as your storage. So you would do a one-time transfer of your data that's sitting in DASD and move it over to S3. There's no real changes to your existing code on the mainframe. As long as you're using the same file system directory name that Zach is managing, there wouldn't be a modification to JCL or anything else as long as you're using that same file system name. The data would look like it's on the mainframe, but also but it'll actually be in S3. So you could migrate vSAM files over there. You could do object backup, storage backup for DB2 or any other data sources that you have on the mainframe. You could use it as a code repository as well, right? For your development environment and your test environments where your COBOL code, for example, could be out in the cloud and it'll you could compile and run the code as if you're still on that mainframe, but the code actually sits in the cloud. In the future, Zach will have the ability to actually write to data stores as well. So right now, the first use case is going to be around storage, virtual disk. Future use cases will have that ability to write to, let's just say, a MySQL database. As long as there's a Fuse driver, we'll be able to write data and file data to that data source off the mainframe. And then Zach will also have the ability to read data sources that are not on the mainframe. So if you've got an existing MongoDB database, for example, or a MySQL, a Postgres database, and you want to update your COBOL program or batch job or whatever online application that's running on the mainframe, you can update that code to actually access that data through Zach going in the future. So, all right. That is the background of our three products and how we integrate with data stores and with storage. We've got plenty of material out there that talks about this in detail. We've even got demos of all three of the products as well. You can go to our site, virtualzcomputing.com, to find all that. We've got some also some blog posts as well that discuss some of the architectures, answer some of the security concerns or constraints that you might have as well. But that's it. That's an overview of how VirtualZ's products work with data stores and storage. So I'll take questions. Hopefully we have some. Did I lose anybody? Did I lose you guys?
No, I think you just did a great job explaining it.
Well, thank you, Ken.
You're welcome.
You can also put a question in the chat if you prefer. And if you don't have any questions, again, we appreciate you joining us. And we would love to hear from you if you do have any comments or questions. And if not, Mark, I'll let you close the call.
We did get one question, I think, before a few questions before the call that I can read real quick. So one was confirming that Propels can do incremental updates. Yes. So I might have covered it too fast originally in the presentation, but again, so if you've got a terabyte file and you want to replicate that entire terabyte file, we can do a one-time replication of that file. And then any time that you want to move data back and you pass in that file into Propels to replicate, you can say that you only want to replicate what's been changed since the last time you ran it. So if you only had 1,000 records added and you ran it a minute ago, it's only going to move the 1,000 records that you added, right? So again, that's a huge benefit from a performance standpoint. It keeps cost in mind from a MIPS standpoint, and it also keeps the network in mind as well. So you're not clogging the network, every time you want to write to a new data source or write to a data source, you're not moving a terabyte of data over every single time. And the performance of it too, I should mention, we've done some basic preliminary testing on a very small mainframe environment, and we were able to move 6,000 records per second over to a database running on Amazon. And again, that network is just a home network. It's not a enterprise network. So that's just the basics we've done. But our base test we've done, we're pretty confident we'll be able to do. So it definitely exceed that when we get into a more enterprise Z15, Z16 mainframe environment with a superior network as well. So.
Thank you, Mark.
Perfect. All right. Well, thank you guys very much. I appreciate it. Thanks, Jeannie, for joining me. And thanks, everybody, for joining the webinar.
All right. Have a great day, everybody. Thank you.